What would happen if two giant galaxies crashed into each other? According to astronomers, this may happen in the far future when the Andromeda Galaxy collides with the Milky Way Galaxy. This possible event is known as the Andromeda-Milky Way collision, and it could completely reshape our cosmic neighborhood. The Milky Way is the galaxy that contains our solar system, Earth, and billions of stars. Andromeda is the nearest large spiral galaxy to us and is located about 2.5 million light-years away. For years, scientists believed the collision between the Milky Way and Andromeda was almost certain. Using data from NASA's Hubble Space Telescope, astronomers discovered that Andromeda is moving toward our galaxy at nearly 110 kilometers per second, or about 250,000 miles per hour. This movement was detected using something called blueshift, which shows objects moving closer through space. Moving forward, don't forget to hit the like button and also subscribe our channel and turn on the bell icon so you never miss our next video. Based on early calculations, scientists predicted the two galaxies would begin colliding in around 4 to 5 billion years. However, newer research has added more uncertainty to the prediction. In 2025, scientists using information from the Gaia spacecraft and the Hubble telescope performed more advanced computer simulations. These simulations tested thousands of possible future paths for both galaxies. The results suggested that a direct head-on collision may not be guaranteed after all. According to the study, there is now about a 50% chance that the Milky Way and Andromeda will collide within the next 10 billion years. Even if the galaxies do not crash directly into each other, they may still pass extremely close together. In some simulations, the two galaxies fly past one another with around 500,000 light-years of space between them. Over time, gravity could slowly pull them back together through a process known as dynamical friction. In other simulations, the galaxies never fully merge at all. Scientists also discovered that nearby galaxies, including the Large Magellanic Cloud and the Triangulum Galaxy, could affect the future movement of both galaxies. Today, the Andromeda Galaxy appears as a faint object in the night sky. Under dark conditions, some people can even see it without a telescope. It looks peaceful and distant, but in reality, Andromeda is slowly moving toward us. Both galaxies are part of a collection of nearby galaxies called the local group. Gravity connects these galaxies together and shapes their future paths. The Milky Way itself is a giant spiral galaxy containing between 100 and 400 billion stars. Andromeda is even larger and may contain around 1 trillion stars. Despite their enormous size, galaxies are mostly empty space. The distance between stars is so massive that even during a galactic collision, stars rarely hit each other directly. Around 2 billion years from now, Andromeda will appear much larger in Earth's sky. As gravity pulls the two galaxies closer together, Andromeda may stretch across a huge part of the night sky. Its bright spiral shape could become clearly visible to anyone looking upward from Earth. At this stage, the galaxies will still remain separate, but their gravitational pull will begin affecting one another more strongly. Gas clouds, stars and dust inside both galaxies may slowly start changing direction due to the increasing gravitational forces. Around 3.75 billion years in the future, the Milky Way and Andromeda will experience their first major close approach. The spiral arms of both galaxies may begin twisting and stretching due to gravity. Long streams of stars and gas could be pulled out into space, creating enormous glowing structures between the galaxies. This stage would dramatically change the appearance of the night sky. The once calm spiral shapes of the galaxies would begin to distort. Scientists believe the collision process would unfold slowly over millions of years rather than happening instantly. At 3.85 billion years from now, gas clouds from both galaxies collide. They will become compressed. This pressure can trigger the birth of many new stars. Large regions of space could suddenly light up with bright young stars, especially hot blue stars that burn very brightly. This process is called a starburst event. Similar events have already been observed in other colliding galaxies, such as the famous Andromeda galaxies. However, scientists believe the Andromeda Milky Way starburst may be weaker because both galaxies could contain less gas by that time in the future. Even so, the sky could become brighter and more colorful as huge star-forming regions appear throughout the merging galaxies. Around 3.9 billion years from now, giant clouds of ionized gas may spread across the sky. These glowing clouds form when radiation from young stars energizes nearby gas. The result could be massive colorful nebula-like structures stretching through space. The Milky Way and Andromeda would no longer look like neat spiral galaxies. Instead, they would appear warped, chaotic, and filled with streams of stars and glowing gas clouds. This stage would mark one of the most dramatic periods in the history of our galaxy. Around 4 billion years in the future, the first major collision between the Milky Way and Andromeda may finally happen. Their outer regions could pass through each other while gravity tears apart the original spiral shapes. Even though billions of stars exist inside both galaxies, actual star collisions are extremely unlikely. The reason is simple. Stars are separated by enormous distances. For example, the nearest star to our Sun, Proxima Centauri, is more than 4 light-years away. To understand this scale, imagine the Sun as a small ping-pong ball. In that example, the nearest star would still be over 1,000 kilometers away. Because of these huge distances, stars inside colliding galaxies usually pass by each other safely. Instead of direct star collisions, gravity causes stars to move into new orbits. Some stars may be thrown farther into space, while others move closer toward the galactic center. During the collision, some stars could be completely ejected from the merged galaxy. Powerful gravitational interactions may slingshot stars outward into deep intergalactic space. Scientists believe our own solar system could move into a new position inside the future galaxy. Some studies suggest there is a 12% chance the solar system may even be thrown out of the merged galaxy entirely. Even if that happened, the planets would likely continue orbiting the Sun normally. The biggest changes would involve our location in the universe and the appearance of the night sky. One of the most powerful events during the merger may involve the giant black holes at the centers of both galaxies. The Milky Way contains a supermassive black hole called Sagittarius A. Andromeda also contains an even larger central black hole. As the galaxies merge, these black holes may slowly move toward one another due to dynamical friction. This process happens when gravitational interactions transfer energy from the black holes to surrounding stars. Over millions of years, the black holes sink closer toward the center of the newly forming galaxy. As the supermassive black holes at the centers of the Milky Way and Andromeda move closer together, the entire structure of the future galaxy could begin changing around them. These black holes are not ordinary objects. The Milky Way's black hole, Sagittarius A, already contains millions of times the mass of the Sun, while Andromeda's central black hole is believed to be even larger. When two objects this massive interact, the effects on surrounding space become extreme. During the final stages of the merger, the black holes would orbit each other at incredible speeds. Their powerful gravity would disturb nearby stars, gas clouds, and dust. Some stars could be flung far away into deep space like cosmic slingshots, while other material may spiral inward toward the black holes. As huge amounts of gas fall into the merging black holes, the surrounding area could heat up to enormous temperatures and begin glowing brighter than entire galaxies. This process may create what scientists call a quasar, one of the brightest objects in the universe. Quasars are powered by supermassive black holes feeding on nearby matter. The energy released from this feeding process can outshine billions of stars combined. If a quasar forms after the Milky Way and Andromeda merge, the center of the new galaxy could become unbelievably bright, blasting radiation across space. The collision would also produce some of the strongest gravitational waves ever created. These ripples in space-time would travel across the universe at the speed of light. Future civilizations in distant galaxies, if they exist, might even detect these waves billions of years later using advanced instruments. Eventually, the two black holes would fully combine into one even larger, supermassive black hole. This final merger would mark the end of one of the most powerful cosmic events in the history of the local group. After millions of years of chaos, the new galaxy would slowly stabilize, leaving behind a single giant black hole at its center. Scientists have explored many possible futures for the solar system during the galactic merger. In some simulations, the Sun moves farther away from the galactic center. In others, it drifts closer toward the newly merged black hole. One extreme possibility suggests the Sun could eventually pass close enough to a supermassive black hole to be torn apart by gravity. If that happened, the Sun's material would spiral into the black hole and release huge amounts of energy. However, scientists believe this outcome is unlikely. Most simulations suggest the solar system would survive the merger without major damage. Even if the solar system survives, Earth itself may not remain habitable long enough to witness the collision. Scientists believe the Sun's brightness is slowly increasing over time. Within about 1:5 billion years, Earth could become too hot for liquid water to exist on its surface. As the Sun grows brighter, temperatures on Earth may rise enough to trigger a runaway greenhouse effect. Oceans could evaporate, and life as we know it would no longer survive. This means Earth's future may already be decided long before the galaxies collide. After the first collision, the galaxies may continue passing through one another multiple times. Around 5.1 billion years from now, the cores of the Milky Way and Andromeda could appear like two bright glowing lobes connected by streams of stars. The galaxies would continue losing their original spiral shapes. Gravity would slowly blend them into a single larger structure. By around 7 billion years in the future, the merger may finally be complete. The Milky Way and Andromeda would combine into a huge new galaxy, sometimes called Milkomeda or Milkdromeda. Scientists believe this future galaxy would probably become a giant elliptical galaxy. Unlike spiral galaxies, elliptical galaxies have smoother shapes and fewer organized spiral arms. Stars inside them move in many different directions rather than following clear circular patterns. However, some researchers believe the final galaxy could instead become a giant lenticular galaxy, or even a super spiral galaxy, depending on how much gas remains after the merger. The Andromeda-Milky Way collision may not be the end of the story. Over the next 150 billion years, many smaller galaxies in the local group could slowly merge into the new giant galaxy as well. Dwarf galaxies already interact with the Milky Way today. For example, the Sagittarius dwarf galaxy is currently being pulled apart and absorbed by our galaxy. Andromeda also appears to have merged with smaller galaxies in the past. Eventually, gravity may pull most galaxies in the local group into one enormous combined structure, completing billions of years of galactic evolution. The possible collision between Andromeda and the Milky Way helps scientists understand how galaxies grow and change over time. Many giant galaxies seen today were likely formed through ancient mergers similar to this future event. By studying galactic collisions, astronomers learn more about gravity, star formation, black holes, and the long-term future of the universe itself. The Andromeda-Milky Way merger also reminds us how dynamic the cosmos truly is. Galaxies are not fixed forever. They move, interact, evolve, and sometimes collide in spectacular ways across billions of years. Even though the collision will happen far beyond any human lifetime, it remains one of the most fascinating future events in astronomy. The idea that our galaxy may someday merge with another giant galaxy captures the imagination of scientists and space fans around the world. The future collision between the Milky Way Galaxy and the Andromeda Galaxy is not simply a story about destruction. It is also a story about transformation and creation. New stars may form, galaxies may reshape themselves, and an entirely new galaxy may rise from the merger. Whether the collision happens directly or not, one thing is certain: the universe is constantly changing on scales so massive that they are difficult for the human mind to fully understand. Stay connected with Planets in Perspective so you never miss any latest updates on everything you want to know about space and its beyond.